Here is 7-2 example 5. We're going to rationalize the denominator of each expression. Again, no absolute value bars necessary because we're assuming all variables are positive. This is going to be a lengthy video, so I'm probably going to pause this once or twice during class, and you might want to do the same at home. Remember, for all of these, the concept is we want to multiply each expression by 1, but that 1 is going to look like something that makes the denominator pop out to be a whole number. For letter A, this one's kind of easy. We're just going to multiply by rad 5 over rad 5. That's equal to 1, but it's going to make rad 5 times rad 5 is rad 25, and rad 25 is 5. 3 times 5 is rad 15. That one's done. Okay, let's do the same thing here for this expression, but we need to use a little common sense. We're taking square roots, and we've already got x squared. So I don't need to multiply by another x. But I do need to make this 3 squared and the y squared. So let's multiply by rad 3y. So that's going to make me have 2 3s and 2 y's. That kind of logic is going to help you, especially when we get to problem C. So let's multiply by the same thing, top and bottom. Okay? And again, the radical property is we multiply everything under the radicals. Let's put it all together. This is going to be radical x, okay, we'll say 3x to the 5th y. We have some simplification to do there here in a minute. And I'm going to write this all underneath one radical so you guys can see how it jumps out. 3 times 3 is 3 squared. We have the x squared. And y times y is y squared. The square root of anything squared is just that thing. So the 3, x, and y are going to jump out to the bottom. So I'll write that down here. Remember, the radical only acts once upon the radicand. X to the 5th is what we have to deal with. Remember, this is an index of 2. X, 5 divided by 2 is 2 remainder 1. So 2 x's are going to jump out. So we have x squared, and what's left under? We still have the 3, 1x, and a y. Okay, a 3, 1x, and a y. Now we have one last simplification step. Remember the quotient rule of like bases. 2 minus this 1. It takes this one out and just leaves 1x up on top. So it's x rad 3xy all over 3y. Kind of cool. Same mentality goes for here, except now we're not looking for square roots. We're looking for cube roots. So I'm going to multiply the denominator by something that's going to make these all perfect cubes. Well, think about it. You've got 1 4 in here. You need 2 more 4s. So why don't we multiply by the square root of, just say it, just 4 squared. See, now I'm going to have 1, 2, 3 4s. Same thing with y. So let's multiply by 2 y's. And we have to do the same thing to the top. 4 squared, y squared. Now on the notes, I wrote the intermediate step. 4 squared is 16. 16 times 5 is 80. So on the top, we're going to have 80 y squared. Okay, and on the bottom, we're going to, same concept as here, except instead of 2 of them this time, I know there's 3 of them. So I have 4y is going to jump out. Okay, but we're not done simplifying yet. There is a perfect cube that goes into 80. Remember the thing to look for that on your calculator. If you don't know where to go, just type in the cube root of 80, and it's 4.3. So some perfect cube of the integers less than this number must be a factor of 80 if it exists. So it's either 1, 2, 3, or 4. Let's cube these and take a look. 1, 8. Aha! 8 is the factor that goes into that. So we can break this up into the cube root of 8 times the cube root of 10y squared all over 4y. The cube root of 8 is 2. 10y squared over 4y, and then 2 takes away, goes into 4 one time. So we're just left with cube root of 10y squared over 2y. Wow.